Hello everyone. The topic I want to do today is metric space. Have you ever heard the term metric before? Yes, you must have. Metric, you have learned about this term in the chapter where we used to measure distance. So, metric is somehow related to distance. So, before starting the topic, I want to discuss some prerequisites. First of all, what a set is. So, a collection of well defined objects is called a set. And when I say well defined, that means there is no confusion about the inclusion or exclusion of an element. There should not be any confusion about what kind of element belong to the collection and which element should not belong to the collection. There should not be any confusion about that. For example, you must have done the set of natural number. This contains elements like 1, 2, 3, 4 and so on. All the counting numbers that we have learned are the element of natural number set. Another set is the set of even number, which contains all the elements that are divisible by 2. For example, 0, 2, 4, 6, 8 and so on. If I say set of odd numbers, then you know that it contains all the elements which are not divisible by 2. For example, 1, 3, 5, 7 and so on. So this was recall of set. One more thing, what an empty set is. The set containing no element. It is a set containing no element. And the representation for empty set is either this or we use 5 for that. So you have done the recall of set, and now I want to recall what a function is. What do you mean by a function? So if you have, let A and B are two sets, then a function f from A to B is a rule or a mapping that assigns to each value of A a unique or exactly one to each value of A exactly one element of B. When I say exactly one, what does it mean? It means that corresponding to every element of A, there is at least one element in B, and corresponding to each element of A, there is at most one element in B. At least and at most. Two conditions are there. Let us see it with examples. If we have a set A containing two elements 1 and 2 and a set B containing three elements A, B and C, and if I have a relation that 1 is related to A, or A is the value assigned to 1, then can I say that this is a function? For this to be a function, it needs to satisfy the condition that for every element in A, there is at least one element in B. But here I have one element in A which do not have any corresponding element in B, which is not assigned any element in B. So this is not a function. Second example is this with a similar set containing two element 1 and 2, B containing three element A, B and C. If a relation is defined like this, 1 goes to A, 1 goes to B and 2 goes to C. Can this be a function? It satisfies the first condition that for every element in A, there is at least one element in B. But the second condition is for every element in A, for each element in A, there should be at most one element in B. But here, corresponding to 1, we have one element A and one element B. So for a single value in A, there are corresponding two values in B. So this also cannot be a function. Now, if you have with the same set A and B, A containing two element 1 and 2, B containing three element A, B and C, if A is related to, if A is assigned to 1 and 2 goes to B, then is this a function? For every element in A, there is at least one element in B. For 1 there is A, for 2 there is B. So first condition is satisfied. Also second condition is for every element in A, there should be at most one element in B. So this condition is also satisfied. For 1 there is only A and for 2 there is only B. Therefore this is a function. So this was a recall for function, and now I can move to the topic. Okay, one more thing before that. In real numbers or in complex number, you have read about the distance. So on real line, if I have any 2 points, say x and y, then how do you define a distance between x and y? Distance between x and y we define as modulus of x minus y. And why this mod sign? Because distance cannot be negative. You know, whenever we measure the distance, say if I have two elements 3 and 6, and I ask you what's the distance between 3 and 6, always you say is 3. So distance is always non-negative in case of real line. Also, second thing, distance of 3 from 6 and distance of 6 from 3 both are the same thing. So distance is symmetric on real line. Distance is symmetric on real line. That means if I interchange the position, the distance does not changes. Does not matter if I am measuring the distance from 3 or if I am measuring the distance from 6. The distance is same. So distance is symmetric on real line. Third thing is identity. If I say the distance between two element x and y is 0, then you can say that x and y are coinciding. That means distance between two element on a real line, distance between two element is 0. Then both the element must coincide. Or if both the element coincide, then distance has to be 0. Triangles inequality, that is something you have also done already. Quality. If I have three elements in real line, then x minus y, distance between x and y is always less than equal to distance between x and z plus distance between z and y. So these four conditions hold in real line. Now I want to define